In this short clip we'll have a quick look at highest common factors and lowest common multiples, and we'll also consider prime factorization. So to find the lowest common multiple of 600 and 850, the first thing that we should do is to prime factorize each of our numbers. If you would like to use a prime factor tree, you can do so. So I start off with 600, and I think of two numbers that multiply to give me 600, so 60 and 10 will do. I put them into a ring if they are not prime numbers. The textbook actually does it the other way around, but there's no great difference either way. Now I think of two numbers that will multiply to give me 60, that would be 6 and 10, and I carry on as shown. So then I've done 6 is 2 times 3, they're prime numbers at the bottom so they don't go in a ring. 10 is 2 times 5, and the other 10 is 2 times 5, and of course at the end of my branches they're all prime numbers. So 600 has the prime factors 2, 3 and 5. 600 can be written as the product of its prime factors as 2 times 2 times 2 times 3 times 5 times 5, or using index notation 2 to the power of 3, 2 cubed, times 3 times 5 to the power of 2, which is 5 squared. I'm going to prime factorize 850 now, but I'm going to use a slightly quicker method. I simply think of two numbers that multiply to give me 850. 10 times 85 will do, and then I'm going to think of two numbers that multiply to give me 10 and two numbers that multiply to give me 85. As it happens, all of the numbers I now have are prime numbers, so I finished. So writing that using index notation, 2 times by 5 squared times by 17. Step 2, we're going to draw a Venn diagram. So I draw my two rings, write 850 next to one of them and 600 next to the other one. The first thing I've got to do is consider which factors these numbers have in common, the 600 and 850, which prime factors, and they'll be written in the middle. So as I look at the numbers, I can see they both have a 2 in common, and they also both have a 5 squared in common, so I'll write that in to begin with. I now look at the number 850 and see which factors I'm missing, 17, and I look at the number 600 and see which numbers are missing for that one. Well, I've used a 2 up in the middle, but I needed 2 cubed, so there's another 2 squared to go in, as you can see, and the 3 was also missing. Okay, so what factors do these two numbers have in common? Well, their common factors are 2, 5 and the 5, 2 and the 5 squared. That means that both numbers can be divided by 2, both numbers can be divided by 5, and both numbers can be divided by 5 squared. If I want to find the highest common factor, all I need to do is multiply together these numbers in the middle, so 2 times 5 squared, which gives me 50. Okay, let me just explain what I've done for the lowest common multiple. If you look at the ring for 850, it contains 17, 2 and 5 squared. If I multiply those numbers together, I obviously get 850. And in fact, if I multiply those numbers by any other whole number, I will get a multiple of 850. If I look at the numbers in the 600 ring, 2, 5 squared, 2 squared and 3, if I multiply them all together, I'll get 600. And if I multiply them all together and multiply by another integer, I will get a multiple of 600. Now what we need is a number that has all of the factors that we can see here. Then it can be divided by 850, and it can also be divided by 600. So we take a product of all of the numbers that we see, 17 times 2 times 5 squared times 2 squared times 3. But of course we can speed things up a little bit. We notice that the 17 times 2 times 5 squared in fact is 850. So I can write that down straight away, 850, you can see in blue at the bottom, and all that's left to do is to multiply this by the 2 squared times 3, which is 12, and if you perform that calculation, you'll get 10,200. So 10,200 contains all of the factors for 850, and it contains all of the factors for 600. And so we're done.